the Mathematical Math Show. I'm your host, Viggy. And today we're going to talk about the unsolved problem of odd perfect numbers. What is a perfect number? A perfect number is a positive integer, which is the sum of all of its factors, not including itself. Today we're going to talk about whether or not odd perfect numbers exist. Let's go find out. Are you still confused? Let's watch a simple demonstration.
A simpler way to look at perfect numbers is like this. So we have 3, which is an odd number, and we're going to try to see if it's a perfect number. So to symbolize perfect numbers, we made a club, and the club is called the Perfect Numbers Club. And 3 wants to get in, but unfortunately for 3, it doesn't know if it's a perfect number. Here we have some of our favorite perfect numbers, 6 and 28. They're perfect numbers, so they can get in the club. But 3 does not have admission in the club. Let's see why not. See, 3 has the factors 1 and 3. And you don't count 3, you add them up, you get 1. 1 equals 1. 1 does not equal 3, and therefore 3 is definitely not a perfect number. So it can't get in the club.
Oh! A necessary component of perfect numbers is aliquot numbers. Let's dive into that.
Aliquot numbers. Aliquot parts of a number are the factors of a number not including itself. These are called proper quotients. For example, 20 has the factors 1, 2, 4, 5, and 10. These occur because 1 is equal to 20 divided by 20, 2 is equal to 20 divided by 10, 4 is equal to 20 divided by 5, 5 is equal to 20 divided by 4, and 10 is equal to 20 divided by 2. This relates to perfect numbers because a perfect number is the sum of the aliquot parts of a number.
The history behind perfect numbers is quite interesting. Let's watch an interview from Pythagoras on the day he died.
Hi, I'm reporting to you live with BBC News in 495 BC. As you can see, Pythagoras is in his domain in this beautiful day studying a textbook. Let's see what he's up to. Hi Pythagoras, my name is Amitesh. What are you up to?
I'm just studying perfect numbers.
So have you found any new ones?
Nope, I only have 6 and 28. I've been thinking so hard, but I can't find any more.
That's it?
That's it. I'm having a heart attack.
Do you have any last words?
I didn't find any more perfect numbers.
Wait, 496. Hey, that's a perfect number. This is easy. Let's see. 8,128. It's a perfect number.
That video had a little historical inaccuracy. Let's watch the actual history.
I love math. History of perfect numbers. The perfect number is said to be discovered during the ancient Egyptian era, but there is written evidence that the early Greeks discovered the first 4 perfect numbers. Philo of Alexandria believed that God created Earth in 6 days because 6 is the smallest perfect number, and the moon revolves around the Earth in 28 days because it is the next perfect number. This was written in his book on the creation. Later, the mathematician Pietro de Catalidi proved all perfect numbers obtained by Euclid's rule ended in a 6 or 8. Marin Mersenne claimed that all of the even perfect numbers are of the form 2 to the power of p minus 1 times 2 to the power of p minus 1. In the 18th century, Euler proved this formula would produce all of the even perfect numbers. Currently, there are 49 even perfect numbers known.
What's cool? The first perfect number is found in Euclid's book. Let's go check that out.
These are the first perfect numbers found. 6, 28, 496, and 8,128. In the equation, we have the perfect number on one side and all the aliquot numbers on the other side. The aliquot numbers do in fact add up to the perfect number. First perfect numbers are found in Euclid's Elements. Euclid states in Euclid's Elements that if as many numbers as we please beginning from a unit be set out continuously in double proportion until the sum of all becomes a prime, and if the sum multiplied into the last makes a number, the product will be perfect. Euclid gives a rigorous proof on the proposition in his book, but we have formula, which we restated as, which is much more modern and simplified, which is 1 plus 2 plus 4 plus etc., ending with 2 to the power of k minus 1 is equal to 2 to the power of k minus 1.
Odd perfect numbers have yet to be found. Many mathematicians deny their existence. How is not proven for sure. We've tried to many odd numbers, but none of them have appeared to become perfect. Watch as we try through the number 945.
945. Are you perfect? Let's take a look at its factors. 1, 945. 3, 315. 5, 189. 7, 135. 9, 105. 15, 63. 21, 45. 27, 35. 945 does not count because when you're checking to see if a number is perfect, you do not count itself. All right, after adding these numbers up, you can see it's 975. Clearly, these two are not equal, and therefore 945 is not a perfect number.
Concludes this episode of Mathematical Math Show. Hope you tune in next time when we discuss calculus.